There's what we're going. Continue in 8.4. And I'm still going to find polynomials. They're going to tell me like what degree they want them, and they're going to give me some zeros, and I'm going to use them zeros to come up with the polynomial. Okay, so sort of like I ended up with doing the other day. So this one we're going to find a polynomial. And they're telling me of a degree 3 with zeros of a -1/5, a 0, and a 4. Now we'll say when you get zeros and a 0, those are your easiest ones. The other ones are the trickier, and you got to do a little more with them. But let me explain what they mean by that. The degree 3, what they mean by that, when you're done, the highest exponent can be a 3 on that. So it can be like an x cubed would be the highest exponent, okay? Anything else, they're not going to let y'all get credit for, okay? So what they're doing, they're giving us the answers basically, and we're going to work in reverse and come up with that polynomial. So since they're giving me the answers, I'm going to set all these equal to x. Now, the goal you want to do to these is get them all equal to 0. So the middle one's good, it's already equal to 0. So I'm going to work on these two and get them equal to 0, okay? So this one, first thing I'm going to do is multiply both sides by 5 to get rid of the fraction. Because that'll give me what, a 5x? The 5 will cancel over there, giving me a -1. And then the last step to get me a 0 here is to add 1 to both sides. So that I get a 5x plus 1 equal to my 0. X equals 0 in the middle is already good. So the last one, x equals 4. I'm just going to subtract 4 from both sides so that I get x minus 4 equals 0. So I've got everything set equal to 0. Now is where I'm going to put all these in parentheses and set the whole thing equal to 0. No, this one right here, I'm going to put in the front because it's a single x. So I'm going to put my single x and then my 5x plus 1 and then my x minus 4 all equal to 0. So to get something like this, if you'd have started with the polynomial, you would have factored it to get to this point or something, and then you would have set them equal to 0 and then solved them, okay? So we're going into reverse. All right, so now it's just a matter of multiplying this stuff together. So what I'm going to do is start with these two right here and FOIL that. So let me bring my x down, and I'll put all this stuff in my big parentheses. So I'm just going to FOIL that. I got a 5x times x is a 5x squared. 5x times -4 is a -20x. I got a 1 times x is just a 1x. And then I got a 1 times -4, which is a -4. All that's still equal to my 0. So before I go further, I can add the like terms in the middle right here. So let's add these like terms real quick. So y'all that'll give me my x. And then I'll have a 5x squared. What's that? -20 and 1 would be a -19x minus my 4, all equal to 0. Okay, so I FOILed it, added my like terms to get to that. So now you just got an x being multiplied by those parentheses. All we have to do now is distribute that x. So that's why we save my single x's for last, because all you got to do is just distribute them and be done. So when you distribute the x through parentheses, you're just adding the x to everybody. That's going to give me a 5x to the third minus a 19x squared minus a 4x all equal to 0. So they wanted a degree 3. I ended up with a degree 3. And I'll tell you, the biggest exponent is always going to equal ever how many zeros you have. So if they give you 3 zeros, that's going to be an x3. If I give you 4 zeros, that'd be an x4 sitting there, okay? Y'all got questions on that? So the main thing is just doing a lot of fun, okay? All right, so let's try and we'll up the I think I'll do this big one here. We're going to look for a degree 6. So that should be scary, right? So degree 6 polynomial. Well, y'all look how they do this one. They say -2 is a 0 of multiplicity 3. That multiplicity 3 means that -2 is a 0 3 times. So I'll have an x equals -2, x equals -2, x equals -2. So that's 3 of my zeros. Then I got 0 is a 0 of multiplicity 2. So that means 0 is going to happen twice for me. And then 2 is a 0 multiplicity 1. But guess what? Add these multiplicities up, 3 zeros, 2 zeros is 5, plus my last 0 gives me my 6 zeros I needed, okay? So, x equals -2 3 times. And I got x equals 0 twice. And then my last one was what? 2 is a 0, so I got 2 that happens 1 time. Thank God we got a few of these that are zeros, because those ain't that, we'll just distribute them later. The ones that bug you is the ones that actually got the numbers there, okay? Because those mean those will be foiled, okay? So once again, you want zeros on the right of all these, so these 2 are good. So I'm just going to add 2 to this one and subtract 2 from those ones, okay? X plus 2 equals 0, so all these will be x plus 2 equals 0. So I'm good on 2 zeros, and then the last one I'll just subtract 2 from both sides and get me an x minus 2 equals 0. Okay. So now I'm going to show you a trick I do to these. I'm going to put the ones with the zeros first. So that's just going to be an x times an x sitting in the front. And then I'm going to put all that stuff in parentheses, okay? So I'm going to have an x plus 2 3 times. And then an x minus 2, all equal to my 0. Now, we'll say on this one, we can save a little time by foiling 2 things at once on this. I'm going to foil these first 2 together. I'm but I'm also going to FOIL my last two together. Now in the front, you got an x times x. I can write that as something else.
X squared.
X squared. So I'll make that an x squared in the front. Then I'm going to FOIL everything else and put it in my parentheses. All right, so here you got an x times x is an x squared. X times 2 is a 2x. 2 times x is another 2x. And then 2 times 2 is a 4. So I just went through and knocked that out real quick. Now I'm going to FOIL this one. Now check this out. X plus 2, x minus 2, those are times you get pairs. Anytime you FOIL conjugate pairs, the middle terms are going to cancel every time. Okay? So here we go. We got an x times x is an x squared. X times negative 2 is a negative 2x. 2 times x is a positive 2x. And then 2 times negative 2 is a negative 4. So I'm going to add like terms, but notice this one does add together, but the other one, like we said, this negative 2x and 2x are going to cancel. Okay? So bringing that down, you got an x squared. This gives me what? X squared. 2 plus 2 is 4x plus the 4. This one gives me an x squared minus 4, all equal to 0. You know, it don't matter what those conjugate pairs are, they're always going to cancel them centers. All right, so unfortunately, we got another FOIL to do. And it's this big one right here. Now, I will say, if you want to make it easier sometimes you can flip these around. If you want the x squared minus 4 first and then the other one. But no matter what, all three of these, you want to multiply by both of those. Okay? So I'm going to bring down that x squared. X squared times x squared. X4. And then we'll do the x squared times negative 4.
Negative 4x squared.
There you go. So then we get to 4x and we're going to distribute it the same way we just did the x squared. The 4x times the x squared.
3.
And then how about the 4x times the negative 4? So that takes care of that 4x get distributed. Now we're going to distribute the 4. So 4 times x squared. And then what's left? 4 times that negative 4. Negative 16. You know, technically all this is still equal to my 0. So I'm going to bring down that x squared again. And add these like terms inside those parentheses real quick. The x4 brings it down because there's no other x4s in here. Let's see what's next. X3. Well, there's only one x cubed in here, so that's going to be a 4x cubed. Ooh, what happened to my x squares?
Cancel.
Yeah, the negative 4 and the positive 4 are going to cancel each other out. Only got the one x, right? The negative 16x. And then my negative 16. So the hard part on this problem is definitely done now, all the FOILing. Now, guess what? This x squared, we're just going to distribute it right through there. Which means basically I'm adding 2 x's to everybody, okay? So x squared x4 gives you x to the 6th. X squared times 4x cubed is a 4x to the 5th. Minus what? 16x to the 3rd minus 16x squared. Woo, so now we're happy. They wanted a what? Degree 6. We ended up with a degree 6, okay? far as the boiling point goes, those are gonna be your trickier problems on that, okay? All right, so switching over to something a little better. All right, so we got some little, you can say rules about these zeros, okay? So some rules about zeros. So, imaginary zeros always come in conjugate pairs. So imaginary zeros always come in conjugate pairs. What I mean by that, if 2i is a zero, then negative 2i is a zero. Okay, if you got an I, then automatically its opposite is going to be a zero too, okay? And that's just because when you're doing the quad formula, remember, the big radical has that plus or minus in front of it. If, I don't know if y'all remember what complex numbers are, but they're like 3 plus 2i type stuff. So if something like 3 plus 4i is a zero, then 3 minus 4i is also a zero. And so it can be single imaginary numbers, or they can be like what we call a complex number with a real part and imaginary, okay? Now notice, I didn't change the sign on the 3. I only changed the sign of that imaginary stuff, okay? All right. Radical zeros always come in conjugate pairs. So if a negative square root of 3 is a zero, then a positive square root of 3 is a zero. So if they only give you a square root of 3 as a zero, you automatically better understand that there will be a negative square root of 3 that's assumed to be the zero also, okay? And then this can come in the form of this. I can have 2 plus the square root of 5. If that's a zero, then 2 minus square root of 5 will be a zero. But y'all, imaginary numbers and radicals, basically they're all radicals. Imaginary numbers are just radicals that have negative numbers under them. Okay. So let me show you what they'll hit you with on these. So on this one, we will find the other zero. So I'm going to find the other zeros. So polynomial degree 4 has zeros of -2, square root of 5, and 11 halves. Find the the other zero. So if my zeros are -2, square root of 5, 11 halves, can y'all get my other zero?
Negative, square root of 5.
Negative square root of 5. That's because these radicals always come in
Pairs.
conjugate pairs. There you go. What about this one? This will be a degree 4 again.
That's the answer. So
Yeah, that's how you're going to put in negative square root of 5 and be done. So thank God for those kind of problems. Now let me up the ante on this one and see what y'all do. So it's another degree 4. So I'm going to find the other zeros. I got a polynomial degree 4. Has zeros of I and 8 minus square root of 11. Find the other zeros. All right, need better markers. So it's those other zeros because that's a polynomial degree 4. They're giving me 2, so I need 2 more.
Negative I, and then a positive,
So a negative I takes care of that one.
and then a 8 plus square root of 11.
8 plus square root of 11. Right, so this is just a 1i, so we change it to a negative 1i. 8 minus square root of 11, remember you only change the sign in front of the radicals, so that's why I say positive 8 plus my square root of 11, okay? So don't think they were doing this to be nice. They just getting you ready for what I got coming up. Okay. So, and then that's why on this example, they don't tell you the degree you're going to end up with. It says find the polynomial of lowest degree. Okay. So find the polynomial of lowest degree with some zeros of a negative 4i and a 5. So, do I have all my zeros? No, I need what?
One more.
And that is?
Positive 4.
Positive 4i. So we got to assume 4i is the other zero. So I'm going to set x equal to all these answers. I got x equals what? 4i, x equals negative 4i, and x equals 5. So that's really why they were just doing this, so that y'all realize when you did that problem that you did have those other zeros coming along. All right, so we need everything on one side equal to 0 on these. So let me minus my 4i. Add 4i to the second one. And then what, minus 5 from the last one. So all of them equal to 0. Now we're going to put them in our parentheses. All equal to 0. Now, I don't know about y'all, but every time I start one of these, I'm starting with the I stuff first. Because when you multiply conjugate pairs of i's, the i's are going to disappear. Okay? So it's one nice thing about conjugates on these imaginary numbers. So I'm going to FOIL this part first. I'll still have that x minus 5 at the end there, okay? All right, so imaginary stuff is sort of tricky to foil, so here we go. X times x is an x squared. X times 4i is a 4ix. Then we do the inside. Negative 4i times x is a negative 4ix. And here comes the tricky part on this. I got a negative 4i times a positive 4i. That's a negative 16i squared. But did y'all see these i's in the middle are going to cancel, ain't they? So those are going to cancel. Do y'all remember what that I squared equals?
-4.
Oh, you're so close to -1. So I squared, if you put it on your calculator, is going to equal -1, okay? So what's going to happen is that -1 multiplied by that -16 is going to make that positive. So you're going to end up with an x squared plus 16. And you know, you can even put that -16i squared on the calculator. It's going to give you a positive 16 out of that, okay? All right, then bring down that x minus 5. All equal to your 0 still. So now this ain't bad. We got 2 things times 2 things. We'll just spoil that and be done. All right, so x times x squared is what, an x to the 3rd minus 5x squared plus 16x. Oh, and then what, 16 times 5 is what, a negative, all equal to 0. Oh, hey, I'm happy that's already in order, ain't it? X cubed, x squared, x and number. We had basically 3 zeros, and we're happy we ended up with a degree 3, okay? It's not too bad, you just gotta get used to the foiling. And remember, anytime you foil imaginary stuff like this, it's going to end up x squared plus whatever number. 100% of the time, imaginary foils end up x squared plus whatever, okay? The radicals will always end up x squared minus the number. Imaginary is always going to be plus, okay? All right, y'all remember the other day we did synthetic division? There it comes. So where I would use synthetic division would be on this example right here. It says the polynomial function has the given 0. We're going to find the other zeros. So the polynomial has the given 0. Find the other zeros. So the function is going to be f of x equals x to the 3rd plus 4x squared minus 5x minus 20. All right, then it's got a, what's that, semicolon and a -4. They're just telling me -4 is my 0, okay? So they're giving me a 0 of -4. I got to find the other 2. Because that's a degree 3, right? Altogether, I need 3 zeros. They're giving me 1. So when they give you 1 0, to find the rest, you knock it out with synthetic division, okay? So watch what I'm going to do. My C is going to be the -4. Whoops, hang on. Let me pull that over a little bit. All right, C is gonna be -4. I'm gonna write down my coefficients. I got a 1, a 4, a -5, and a -20. And then I just draw my little box. Check this out. Since I know -4 is a 0 that they're giving me, when I'm done, that better be a 0. To be a 0, your remainder has to be 0, okay? So if you don't get a 0 remainder, that means you did something a little bit bad on your dividing through here, okay? All right, so the thing is, the first number always comes straight down. Then you're going to take this number, multiply by the C. So 1 times -4 is -4. And that goes into your next column. Then you want to add those up and get me an answer. Oh, that's nice. That's going to give me what, a big 0 right here. Repeat the process. 0 times -4 is 0. So that'll go right here now. So see, you're just going bam, 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 bam. Take that answer. Keep going through, okay? Well, -5 plus 0 is a -5. And I know what better be there. -5 times -4 is a 20, which gives me a 0 remainder. But we knew that because they gave us that -4. Now, I got 3 numbers here, right? Once we get it down to 3 numbers, so once we get 3 numbers, we can use the quad. We can now use the quad formula on that. So at this point, we're hoping y'all are using your calculator program for this quad. They can do it by hand if you want, but whew. Hey, and these ain't bad either. I'll tell you what this means. This is what you would get as your quotient if you divided this polynomial by the -4. And these numbers always start 1 degree less than this. So since that was an x3, this means that this is technically 1x squared plus 0x minus 5. Okay? That's why when you get it down to x squared, we can hit it on the quad and be done. So y'all should have got some radical answers on this. Y'all get like a plus minus square root of 5?
X squared minus 5.
Oh no, be clear. I go to program. Let's see.
Maybe from the back.
Oh, it's freezing up my head.
Yeah.
So I got. Yeah, it should be. And we don't even have to write the zeros, just the plus or minus square root of 5 part. So slide over a few chairs and there's your plugger. Oh, but I ain't got a, dang it.
It's
Oh,
okay.
well.
We can do it farther than
I got a block.
You got a block? Okay, so we'll hook it up. You don't take it very long to charge, I don't think. So yeah, if you saw that on the calculator, it gave you 0 plus square root of 5, 0 minus square root of 5. All you gotta put in math lab is the plus or minus square root of 5, okay? So 2 zeros here. The -4 they gave me was my 3 zeros, okay? I'm gonna do this one and then I'll play that other stuff. right, same thing. I'm gonna find a polynomial lowest degree. This time they're giving me P of X equals X to the fourth plus 55 X squared minus 576. This time, the zero they're giving me is 8i. So I'll probably have to Zoom with y'all a little bit Friday. So I'm not really able to Zoom at home right now. My internet's too bad. U-Bear sucks. So I'll be up here Friday if any of y'all want to come up here Friday from 10 to 11 or whatever. Okay. If not, just hit me on the Zoom. Okay. They're giving me 1, 0, which is 8i. Now look here, I want to have 4 zeros on this one, okay? So I'm gonna bring down that 8i. Now here's the trick on this one. Since it's an x4, I've got to do synthetic division twice before I can get it down using my quad, okay? All right, I'm gonna write my coefficients. So the first number will be a 1. What would I put next?
55.
It. Oh, y'all remember? Because remember, I got an x4. Here's my x2. What am I going to put for my x3 term?
0.
0. There you go. So this is where they actually snuck in one where you had to put some zeros on it. Then I got my what? My 55. But then guess what? I got another what?
0.
Uh-huh. And then my negative 576. Now we know we're going to get a 0 remainder because they gave me this 0, okay? All right, the first number comes straight down again. 1 times 8i. Dude, that's an 8i. 0 plus 8i. 8i, right? Uh-oh. 8i times 8i. So y'all, 8i times 8i is a 64i squared. But what do we say I squared equals? Negative 1. So it's going to turn that 64i squared into a negative 64. So this is negative 64 now. So if you notice, the I squared always ends up changing the sign and it goes, okay? So now, negative 64 and 55 is a negative, what, 9? Negative 9 times 8i. What's that, negative 72i? Well, plus a 0 is going to leave that at negative 72i. So now we're going to multiply that 8i times that negative 72i. That's going to give you a negative 576i squared. So what's I squared doing to that?
Changing the sign.
Changing the sign. So that's going to be what, a positive 576. Which is what I needed here, right? Because I have to get a 0 on this because they gave it to me. So 576 added gives me a 0. Oh, but y'all, I can't use quad yet because I got 4 numbers instead of 3, okay? So what we're going to have to do now is do synthetic again. Now here's the thing. Since I'm doing synthetic for the second time, these are going to be the coefficients I'm using. I no longer use those 5. I go down to these 4, okay? So my coefficients will be the 1, the 8i, negative 9, negative 72i. Oh, snap. I don't know what 0 to try. I'm totally gone. I need a zero that I can check.
It's just zero.
1.
Oh, no. It's something that we did just a second ago that should be ringing a bell on you. What was the first zero they gave me?
Oh, negative 8i.
Negative 8i. Remember, these conjugate ones always come in conjugate pairs. So here you would need your negative 8i. See, that's where they incorporate that now, and they say, well, hell, they should know that now, so we'll just give them the 8i, and they better know there's a negative 8i, okay? Now, once we do this, we're going to get 3 numbers. We're going to hit with the quad after we knock out this one, okay? So we bring down our 1 again. But y'all know, this 8i stuff is going to clear out pretty quick. Because 1 times negative 8i is a negative 8i. But then when you add that, you get a big O 0. Well, 0 times negative 8i is still a 0. Negative 9 and 0 is negative 9. And look at that. Negative 9 times negative 8i is a 72i, which now gives me a remainder of 0. So I know the first 0 was a negative 8i. Now, I got 3 numbers. I'm going to use the quad. So use the quad. And I think on that, you should actually get 2 nice numbers like what? Plus or minus 3. Now, these will be done by hand if y'all like doing that quad and stuff. But that's why we wanted y'all to get them programs, because in this section, you're going to do quite a lot on these kind of problems, okay? All right, that's pretty much. So Friday, I just got a little bit to do with y'all. So if y'all want to come up here, I'll probably come up here Friday from 10 to 11. If y'all want to Zoom, I'll pull Zoom up and y'all can get on Zoom, okay? That way I'm trying to get us back on schedule from losing that week of ice storm hit us, remember? So we'll get there because I always load mine up more on the first end than at the last. Usually I like more time studying for them finals and stuff. So questions on this, y'all? I mean, today was a lot of foiling and a little bit of synthetic division type stuff. And just remember them radicals and imaginaries come in conjugate pairs, okay? And then have fun foiling, I guess. Because y'all doing a lot of foiling. Any questions online?
You'll be next door today?
Mm-hmm. Yeah. All right, y'all. So I'll end this and I'll get this video sent out and I will see y'all Friday. Y'all have a good day.